Basic Calculus Part 1, Differentiation from First Principles. This follows on from the video on average gradients, so I suggest that you watch that one first if you haven't done so, so you are fully aware of what we're doing here. In average gradient, we spoke about 2 points A and B on the line y equals f of x. When we have x, then the y value is f of x. When we have x plus h, a distance of h away, we have f of x plus h. Now, what's going to happen as b approaches a? What's going to happen to h? H is getting closer and closer to 0. Then we looked at the average gradient where we said that y value minus that y value over that x value minus that x value. So it was f of x plus h minus f of x over h. As b reaches a, this line from a to b becomes a tangent. Now there's the f of x plus h minus f of x all over x plus h minus x, which becomes h below. And calculate the limit of that as h tends to 0. Well, there we are. The limit of that as h tends to 0. Well, that's in simplest form at the moment unless we know the value of the function, know more about the function f of x, y equals f of x. So the question is, what is the gradient of f of x at x? What's the gradient of the tangent to the curve? Because when we talk about the tangent, the gradient of a curve, we mean the gradient of the tangent to the curve. What's the gradient of that line? Well, the gradient of that line is this limit as h tended to 0. So therefore, that is also the gradient of the line. So let's have a look at some exercises, right? First, let's work out some limits. Just a case of multiplying out, substituting 0 for h. Multiplying out, simplifying. Now we can substitute 0 for h, and we get 6. Notice the limits written on every line. And finally, there's no limit written there because we've substituted. Multiply out the top, simplify. Now we can take out a common factor of h. If we substituted 0 for h there, we get 0 over 0. And remember, 0 over 0 is indeterminate. It tells us something could have happened first. Well, in this case, we can take out an h, and they can cancel. So we're left with just the limit as h tends to 0 of 8x plus 4h. Notice, limit, 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 limit. Now, we're not going to write limit on the next line because we're going to substitute the h, the 0 for h. I cannot remind you enough about having to write limit on every line until the substitution. Same sort of question, where we have to do the substitution. So if f of x is 4x plus 5 and f of x plus h is, and we put x plus h instead of x. There we are. F of x plus h in blue, there it is there, 4x minus 5, so x plus h, 4 times x plus h minus 5. Minus f of x minus, well, there's f of x, don't forget the brackets. Simplifying, and you're reminded that the limit of a constant is always the constant. So therefore the answer is 4. If f of x equals 8, what's f of 1? It's 8. F of 2 is 8. F of 3 is 8. F of 20 is 8. F of x is constantly 8. So what's f of x? Plus h. Well, if we substitute x plus h for x in there, we end up with 8. So therefore f of x plus h minus f of x is 8 minus 8. There we are. Some exercises to do yourself. Pause, try them yourself, then go through the answers. Notice limit as h tends to 0 until we substitute the 0 for h. Limit as h tends to 0 until we substituted the 0 for h. Now we substitute, so the limit h tends to 0 goes. X plus h to the minus 1 means 1 over x plus h, x to the minus 1, 1 over x. Zero in for h means x times x, so we have x squared below. Negative just transfers to the whole fraction. Limit of 5 as h tends to 0. Well, 5 is a constant, so 5 stays as 5. 5 is 5 is 5. Therefore, the limit is 5. Now we have to find f of x plus h by putting x plus h instead of x. So therefore, this whole bit here is f of x plus h. Notice x plus h instead of x plus 1. X plus h instead of x plus 1. Minus, and don't forget the bracket for the f of x. If f of x is 4, that's a constant, so f of anything will be 4, so f of x plus h is 4, f of 4 is 4, f of 4 is 4. Now, this here that we've been finding is called the derivative of f of x. F prime of x. So we write it with a little angled dash there of x. But we say f prime of x, or f prime x. There, we did that in an earlier example. That means the derivative of f of x is 4. F prime of x equals 4. F prime x equals 4. It's the instant gradient of a function. Remember, f of x plus h minus f of x all over h came from the average gradient. And then we made h go to 0, so that a and b became the same point, the gradient at that point, a. A repetition of what we did earlier as a reminder. And the derivative is the gradient, but it's also the rate of change, because how fast it is changing is dependent on the ratio of y to x. So therefore the rate of change of y, change in y over change in x, or f of x. So therefore f prime x, the derivative, is the gradient of the tangent to the curve, and it's also the rate of change of the curve at that point. And the process is called differentiation. So we differentiate to get the derivative. Right, that's first principles, where we found the limit of f of x plus h minus f of x all over h. That's the same as completing the square. You only do it if you are told to use it. You don't complete the square. There are far quicker methods. You don't complete the square unless you're told to do it that way. But if you're told to do it that way, then you must do it that way. Right, and the second method, much faster. We'll deal with it later. So in each case, we need to find the derivative. Find f prime of x, f prime x. We have to differentiate. So let's start with the first one. A reminder. There is your average gradient, f of x plus h minus f of x all over h. Now we're going to substitute x plus h for x in the blue and take f of x as it is in brackets. Notice the sign change. There is f prime x, 7. Remember that the derivative is the gradient of the curve. Well, have a look. This is a linear function. It's a straight line function, so the gradient is always 7. Well, the derivative says so too. This one's going to have a variable gradient, so therefore the derivative must have a variable in it. The blue, I've substituted x plus h, x plus h. Now it's just algebraic simplification. When you're doing differentiation from first principles, if every term without an h doesn't go, then you have an error somewhere. Have a look. 3x squared has no h, there's a minus 3x squared. Minus 7x has no h, there's a plus 7x. Plus 2 has no h, there's a minus 2. Common factor, cancel, and now we substitute our 0. And there is our derivative. There is our f prime x, there is the gradient of the curve. Now notice it has an x in it because this is a parabola. And it has a varying gradient depending on the value of x. X cubed. Right. So that's x plus h all cubed. Now that's a case of just multiplying out. There we are. When you cube something, you square it and then multiply by itself again. So it's x plus h times x plus h squared. There's x plus h squared. multiply by x plus h, simplify. That's how we end up with that. Notice there's a term without an h, cancels with the other term without an h. So all of them now have h's. So we have a common factor. There it is. Limit, 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 limit all the way down. We haven't substituted yet, but on the next line I'm going to substitute. 3xh goes because h is 0 and h squared goes. So there is the derivative of f of x equals x cubed. It's the gradient of f of x equals x cubed. So f of x plus h, 1 over x plus h all squared, minus f of x. Common denominator on the top line. Because there's no fraction on the bottom, this denominator here can just slot in with that one. Notice the sign change. X plus h all squared is x squared plus 2xh, but it's got a minus outside, minus. Plus h squared, sign change. That h and that h can cancel. These h's can't. That's one of two terms. That's one of two terms. Limit all the way down, but now we can substitute 0 there, 0 there. So we'll end up with 2x over x to the 4, negative 2x over x to the 4, which simplifies to 2 over x cubed, negative. Some exercises for you. Pause, try them, then go through the answers. Limit of 2 as h tends to 0, 2 is a constant, therefore the limit is 2. F of x plus h will be 5. F of anything is 5. Here as well, x is the variable, so if we have k, we see k as a constant, so therefore f of x plus h is also k. Limit h tends to 0 all the way down because we have not substituted yet. Now we substituted. In this one, the blues are going to have two terms, x plus h all squared minus 5 times x plus h. There's an x squared without an h. There's a minus 5x without an h. They have terms to cancel them out. Sorry, this should have an h outside it, over h. And this is already cancelled, that's why. H has come out cancelled with the h. Common denominator. Notice the sign changes.